So thanks, Kishore, for setting up that context. My name is Panchakshari. I'm helped by Netra, who will be building the pipeline itself. But before we jump into building the pipeline in 30 minutes, let me set up a little more context on what we are trying to do today and what Condense is about and things like that. So today, when we really talk about uh, vehicle data, the what we really are talking about is the data streaming part of itself. So whether it's the location, the vehicle telemetry data, the diagnostic data, the emergency alerts, data that is coming in constantly from these vehicles, and we are expected to act on it in real time. Now, building real-time data seems very simple in theory, but in practice, it usually means stitching together a lot of technologies, a lot of tools, Kafka for streaming, and then Flim for handling the stateful integrations, API gateways for facilitating the downstream applications, Prometheus or Grafana for monitoring the data, and of course, for being agile, there is an integration that needs to be done with CI/CD kind of infrastructure tools, etc. And all this adds up quickly as an ecosystem. So this is where Condense comes into picture. This is exactly the problem why Condense was built for. Condense is a Kafka native real-time data streaming platform. It is fully managed in nature. It's cloud agnostic, and it's designed to help teams focus on use cases and outcomes, not to worry about deploying resources, managing infrastructure, and things like that. Let's try to take a look at it in a visual way. Nitra, if you could bring in the slide. So if you see the bottom half of the slide here, what you will see is a lot of technologies and tools which are required to even facilitate a data streaming. So if you see, there are external interfaces which needs to be glued together. There are observability tools like Grafana, Prometheus, which needs to be scripted so that you could monitor the underlying infrastructure. And then there are queues, as mentioned, there is Kafka inside it. And in order to facilitate a real use case, there are microservices or applications that needs to be built around this Kafka. And of course, there are databases which needs this information for later analysis. And underlying powering all of these is the cloud infrastructure, which needs to be managed so that there is no downtime and your cloud costs are optimal in nature. And now, if you see the top half of the slide, you see all of this hassle is gone, and there is an unified platform called as Condense, which completely manages and glues all the underlying technologies that are there, so that you could completely focus on building newer use cases and building application specific things so that the outcomes would be realized from an application front. So talking about Condense, it's a fully managed Kafka, which brings in the verticalized nature. When I say verticalized nature, it is the domain specific intelligence. So specifically talking about domain specific intelligence, it features in the pre-built connectors which are specific to a domain. It features in pre-built transforms which are specific to a domain. So if I have to just name a couple of examples, first we go into deeper by building one of such use cases by using these connectors in the later part of the presentation. So it would be the telematics connectors, the transformations that are required for fleet management systems and things like that. And all of this would be monitored by an inbuilt observability platform, which is inbuilt and which is native in nature to Condense. And if you see what Condense really facilitates here is not to worry about the underlying technologies and not to worry about the infrastructure that hosts these technologies by facilitating use case building and the outcome driven architectures. And all of this is deployed on the customer's cloud, on the customer's cloud, so that it facilitates data sovereignty. Specifically, why does it really matter to bigger companies like OEMs, tier one manufacturers, and large fleets? Is because of the regional compliance and what is happening across the across the world and all around geopolitics and things like that. So, though data sovereignty considering one of the aspects for BYOC, also you get flexibility with respect to billing, and then there are these pre-purchase credits that you often get from cloud providers like AWS, Azure, and GCP, which could be retired for using Condense. Now let's talk a little about observability itself, because that plays a very important part in understanding what is happening with the underlying infrastructure, and also that there should be a transparent nature that is required for bringing into picture, so that you get an understanding of what Condense is really doing at an infrastructure layer, so that there is clarity and understanding about what happens within Condense. So that you could monitor the data that is incoming in the ingress of it, the egress of it, the average throughput that is across the pipeline, and also you will be able to understand what is happening with the custom transform framework. So I'll go a little deeper into this custom transform framework when we jump into the use case. But as of now, you consider this as a framework which facilitates writing applications and writing event-driven microservices. So all of this was part of Condense on a nutshell. Let's quickly jump onto the use case that we were planning to build today within 30 minutes. And it would be specifically for the mobility domain, and mostly around the telematics devices and what is required for the fleet management systems. So what we essentially would build in this 30 minutes is get in the pre-built connectors which are already passing the data for telematics devices from a manufacturer called as iTriangle and from a manufacturer called as Teltonica, and then bring in this data into a transformation layer, which gets transformed and split into periodic and then the event driven and the events, and then essentially use this data and push that data to the downstream application, which is a fleet management solution, and then also push it into a database, which would eventually be used for batch processing and understanding the analytics around what is happening with the vehicle. So yeah, let's quickly jump onto the use case, Netra, then. So if you could bring in Condense. So this is the login page that Condense offers today. So if you see that there is a sign up that is required here, of course, Netra is already signed up and she is part of an organization. Now she is trying to log in. But when you initially get onto Condense, you have to sign up and give a little more details about the organization, the member, and a little more details around that. So now as soon as we log in, there is a workspace. We land onto a place called as workspace. So these workspaces are different applications or different pipelines that are built. So if you see what really this workspace offers is a logical separation or a segregation between these pipelines, so that it would eventually help for different teams to build different pipelines and also an RBAC to facilitate what access of data, what data access is required for what roles and what members, etc. So before we jump on to building the new workspace, I just talked about the RBAC. Let's go to the settings page and then try to understand a little more details about it. So if you go down a little, Vitra, so you see that each of these applications or each of these pipelines which are built are slightly go up. So are built are having specific the workspaces. So each of these workspaces, if you see that there is a specific RBAC and we would give access to specific people here. And now if you go down, there are different members who are part of this organization, and you could see that there are some admins, some users. So, and these members would be, or these roles would be tagged to the workspaces itself. So this is a brief about RBAC, and it also hosts a lot of other features. So we could quickly head on to documentation and look around that. But right now we'll just jump onto the pipeline building phase so that we could really facilitate a use case that we've thought of. So jump onto the workspaces. Or before that, we are using, as I mentioned, we'll be using the custom transform framework, which brings in the code that you already have. So for that, you need to connect one of the versioning management system. So right now we will connect to one of them, which is GitLab. So Netra will be connecting to a GitLab. So there are some. So now if you see that GitLab is connected to Netra's Git, now let's go to the pipeline. Let's go to workspace and then let's start building things. Okay, now if you see that there is a workspace that we have created. Netra, if you could also help us create a new workspace so that we could give an information about what is really. Yeah, if you could see here now, if we click on add new workspace, you could write the name of the workspace and the description of the workspace and things like that. And now, as soon as you create the workspace, you will see a blank canvas where you will be able to really start building the pipeline. So now I take quickly a few minutes to really understand, help you guys understand what connectors is, what applications is, and what KSQL is. So if you see here, there are two aspects of connectors which are visible. One is your connectors, the other one is pre-built connectors. So your connectors connects to the applications page. That is where we created the Git. So as soon as you bring in your coding contents and builds it as we build them as part of your connectors, so they will be visible as part of your connectors and you could use them at a later stage in the pipelines. And now talking about pre-built connectors, so these are pre-built by Zeliot, and they are in an evolution phase. And if you come back after 10 days, then there might be a couple of new connectors that might have got added into this. So these are very industry specific in nature. You could see that there are a couple of telematics devices. There are database connectors. There are downstream application connectors, and etc. And now let's move to applications. So this is where I think the connection with Git would be used. And if you see, this will be the place where we'll be adding the applications and we'll be building. So the entire journey of creating an application or a logic which will be used by the pipeline ultimately, and then taking it through a journey of managing it and maintaining it will be completely internal to Condense. So this was a brief about the feature set, and then let's quickly jump on to the pipelines. So now let's start working on the pipeline that we'll be envisaging today. So you see that, as I mentioned earlier, there are two telematics devices here. One from a manufacturer called as Teltonica, which is, I guess it's FMB 130 device, and the other is from a manufacturer called as iTriangle, which is Bharat 101. And these are already configured. So if you could click on one of them, so these are already pre-configured. As you know that when we deploy these connectors, so there is an IP port that gets generated and which has to be configured on these telematics devices. So we have pre-configured that, and on bench or on a demo vehicle, we have set up these devices so that it would be easier for us to take the data and start working on it. But essentially, having said that, it just takes few minutes to deploy this connector from the connectors page, and the configuration that is just required is the title and the output topic, and all of the data that is coming from telematics devices, which is raw in nature, is parsed and it is available on the output topic. So this just happens in 2-3 minutes, and you're able to start. You'll be able to start using the data, and then you could build on it. So now, if you click on logs, so now the devices are live, and you are able to see that there is parsed data from the raw data that is coming from telematics devices. All of this is facilitated by the pre-built connector, which is called as Bharat 101. So now let's go back, and also you could essentially see the data that is part of the telematics device, which is like the geolocation, the vehicle information, and things like that. So, and similarly, you have to configure similar configuration is required for the FMB 130 device of Teltonica, and also when you click on logs, you'll be able to see the logs that are parsed. Yeah, some configurations required. Yeah. So now you are able to see the logs which are parsed from this Teltonica connector. Now let's go back. So now if you see, we'll build on this these two telematics devices. Let's start building by splitting the data into the events and the periodic data. So as you know that as you know that the telematics devices are sending two kinds of packets. One is the periodic, the other is the events. So if you could see that, we'll start building in the periodic data now. So you see that there's a pre-built connector which is splitting the data from the data that is coming from these telematics devices. So there are a couple of configurations required. Underlying these connectors are working on Kafka. So that is why we have to input credentials related to Kafka. As you can see that there are a couple of credentials like the broker name, the username, password, consumer group. And then I would also explain why the configuration of Redis is coming into picture here. So the consumer group. Yeah. So now essentially the selection of topic. So you see that the data that is pushed onto the output topic by the telematics devices is consumed by the periodic connector. So you see that the input, now we could publish it, Netra, so that we could see the connection between these two. Yeah. So now if you see that there is a connection between the telematics devices and the periodic connector. So the telematics devices are publishing one input topic, and that input topic is consumed by the periodic connector. And again, the periodic connector is pushing data to the output topic. So what essentially the periodic connector does is it takes data from these telematics devices and segregates the periodic data from the event data, and then pushes that to a later stage of application building. So now let's proceed further with respect to the application building. So let's push this data onto a fleet management solution by using one of the connector which is already pre-built. Please go ahead with the configuration. So now we could see that there is configuration required. So all these are pre-built connectors which are pre-built, and you will be able to configure this in less than few minutes and start working on these connectors. So now again, similar kind of configurations where we are consuming from the input topic, from the output topic of the previous connector, and then push this information onto the output topic. Yeah, so see that the similar kind of configurations are required for Kafka, the broker, the username and password. Yeah, essentially it's like we are considering a couple of configuration parameters, and this connector is pushing information onto a fleet management solution which is called as Aquila Drag, and this is outside condense. So what essentially is happening here is the backend part of it, or the building part of it, is done on condense, and then the front end part of it, which is outside and which handles all the workflows related to the customers itself, is outside condense, and data is being put from one Kafka topic which is inside condense to the other topic which is outside condense, and which is on the fleet management solution, so that there is a logical segregation between these two. And now I think we have established connection with Aquila Track, and it would be pushing information. It would be pushing the periodic information on the Aquila Track. So we'll see the complete workflow from start to end at the end of at the later stage of the presentation. And now let's start pushing this information onto a database. So now we have pushed it into a downstream application called as fleet management solution. Now let's push this periodic data onto a Postgres SQL database so that it could be used at a later stage for analysis. So this is the typical architecture where you get information from a telematics devices basically, and do a small modification on that, segregate that data from event data to periodic data. And of course, there will be a little more or much more applications which revolve around this periodic data. But for today's case, we are just taking data from these telematics devices and pushing them to a downstream application, which is Aquila track, and then to a database, which is a Postgres SQL database. So now you could see that the credentials which are required here are for the database and also the Kafka topic. Yeah, the schema is already decided here and designed, and the data which is coming from the telematics devices is put in this schema and then being pushed to the database. So Netra, if you could click on these and show the logs so that we get an understanding of how this data is being pushed. Yeah. So now you could see that there are a couple of parameters which are considered in the periodic data logs. So this connector is essentially pulling periodic data from the telematics devices. So let's go further. And this data is consumed by Aquila track connector, and you could see that there's a format in which this data is aligned to, and this data is being pushed onto Aquila track. So the connection between condense and the FMS solution is again Kafka. So there is a Kafka push or a Kafka publisher from condense, and there is a Kafka consumer which is on the fleet management solution, which is consuming this information and ultimately publishing it to the front end. So now let's go back and let's go to the database. And now you could see that based on schema, the data is being pushed onto the database. So now we have achieved an end-to-end stream of information from the telematics devices, segregated into periodic data and being pushed onto a fleet management solution and a database for analysis at a further stage. Now let's skip to the other domain of the telematics device, which is handling the event data itself. Netra, if you could add on. Yeah, I think now we are trying to utilize the applications page, and this is one of the features that I spoke about, which is called as custom transform framework, where we could bring in the code which is there outside with the application which is there outside onto condense, and then do some manipulations and then ultimately push the data to the downstream applications. So now you can see that the connection with the Git has happened. We are selecting one of the applications which is built on which is built and which is there in the Git, so which is called as detecting panic alerts and then pushing that information onto the FMS solution. So let's give in a couple of minutes to it to load. Essentially, what this algorithm is bringing to the table is taking the data from the telematics devices, segregating that data from the periodic data to the event data. And on the event data, we are specifically choosing panic alerts which are getting generated from the vehicle. Of course, there will be multiple alerts that get generated from the telematics devices like harsh acceleration, braking, longitudinal acceleration, all of the events which are very specific to the vehicle. And now we are taking this information and then segregating a panic alert from all of this information and then using that so that we could push that onto an FMS solution. So, and also very important aspect here is the code that is getting, the link that is getting created to Git here, and we'll bring in the code that is available on Git. It poses couple of aspects. So there is a Docker file which gives an understanding about how the deployment will happen and how the deployment will happen and the configurations related to the deployment. and then we can see the actual code itself, which has a couple of environment variables that we will talk about. There will be input topic, which will consume data from the previous publisher, and there will be output topic, which will be again published for to the downstream applications. And then there are some configurations that are done for storing the data, which is metadata in the Redis, which is already available as part of condense, so that we do not generate these panic alerts as soon as a packet arrives. So we just generate a panic alert for once, and then we keep that for a duration until the panic is actually uh, actually being served. So there are a couple of applications or actions which gets triggered out of this. So specifically when it comes to emergency in the European region, if you see, so whenever an emergency button is pressed, there is an emergency response team that gets triggered, so which could eventually help the on ground situation and handle the situation. So I think it's taking a bit of time to load. Let's wait. Give it in for another couple of minutes. Yeah, now I think it's loaded completely. So now you could see I was talking about Docker file. So now it's the code that um yeah, it's code that is there. You could see that now let's publish this and go ahead and start using the environment variables. So I already spoke about what actually the code is about. So you could see, essentially it's about taking the data from the telematics devices and then segregating a panic alert from all of the other alerts, and then using this now as soon as it is published. So this is getting published onto your connectors, as I mentioned earlier. And also, as you see that the environment variables that soon we will be using, so this structure is created in order to bring in the reusability part of it. So at a later stage, whenever you want to bring in you want to reuse this connector, you just have to configure these environment variables and start using them. So let's see, as you can see that the logs are also getting printed. So you could see what is happening with the deployment itself, so that we can really understand and take actions if any actions are required. So as you know that these deployments usually take some time, because underlying it has to gather the infrastructure that is required, it has to manipulate them, and then start deploying these containerized applications onto the infrastructure itself. Okay, let's so it's building. So as you can see that this is one of the applications that is there on the custom transform framework. So the custom transform framework, if I have to explain it a little more, so the applications which are built on custom transform framework, from bringing in the Git code and publishing them, and then ultimately deploying them and managing them on Condense, is a whole journey that you can take on Condense. As soon as you deploy these applications on the pipeline, these applications are fully managed in nature. So whenever the scale hits, like if there is a load that gets that suddenly adds up, these applications scale themselves automatically and scale down themselves automatically, so that the load is facilitated, and also the cost is optimized in nature, because you essentially will not deploy huge amount of resources to manage these applications itself. Yeah, it's still in progress. Okay, so now you can see that the logs are the because you could see the logs. Nitra, if you scroll a little up, you will be able to. Yeah, now you could see that there is a unique ID that has got generated for the stream, and then there is a digest which gets this information. All this is used for understanding what is happening with the image which is getting deployed. So let's give in few minutes. It will ultimately get deployed on the pipeline so that we could start configuring it. Yeah. Now there is a last step that is present. Okay, yeah, it's successfully tagged and it is, I think it will deploy now. Yeah. So now it's completely deployed and you're able to see so now let's go get on to configuring the inways. So you could see that this essentially is done in order to facilitate reusability of the connector itself. So there are a couple of parameters which are required. Underlying, since Kafka is the queue that is used, so you'll be able to you have to bring in the broker name, the username, password, and then the consumer group and the topic names, the input topic and the output topic. So let's bring in these. And also, if you see that there is a configuration that is required for using the internal Redis itself. Because as I mentioned earlier, we are using Redis in order to store the configurations. So yeah, now so now the configurations required are added. So these are envs which could be utilized at a later stage. So we'll fill in this as soon as we get on to using the connector in the pipeline stage. Yeah, now it's published and you could see that it is published to your connectors. So whatever that we get on from the custom transform framework will be published as part of your connectors. So now as soon as you see that the env variables are being filled in. So the same, I mean, underlying it's the same configuration because as you can see that there is Kafka which is used at the underlying layer. Consumer group is panic underscore alert underscore data. So now we could see that we are consuming information from the input topic, which is used by the telematics device connectors to publish data. So now this is the output topic which we are publishing from this connector, from the panic-alert connector. This is the Redis configuration which is done, and the output topic is panic underscore Aquila track that we publish. And now you could see that there is panic-alert connector or a transformation that is added, which is consuming information from the telematics devices. So essentially, as I mentioned, this connector utilizes the data from the telematics devices and splits that into an event data, and so more so specific to a panic information, and then it publishes that information onto the output topic. So let's see, I mean, as Netra is configuring, let's also see that whenever the panic button is pressed on the vehicle. So Rakesh, if you could help us in pressing the panic button on the vehicle so that we could see the locks on the connector. So now you can see that there is a demo vehicle that has been set up, which has the VI triangle device and the telectronic device. Now you could press in panic button, Rakesh. Yeah, I think now the panic button is being pressed. As soon as this configuration is done, we'll go ahead and see the alerts getting generated from the telematics devices. And these alerts which are getting generated from the telematics devices are ultimately consumed by the telematics data connectors, and they are parsed into readable format into a JSON structure and ultimately consumed by the panic alert transformation. And this panic alert transformation pushes this information onto the FMS solution and the database. Let's wait till the configurations are set up. So you could see these are similar configurations which are done earlier for pushing the periodic data onto the FMS solution and the database. So now you can see that the whole pipeline is created. So there are two telematics devices. Mitra, before we jump on to explaining the whole pipeline, if you could click on Panic Alert and showcase the logs, I could change yeah. So now you can see that the alerts are getting generated, and from all of the telemetry data that is sent from the telematics devices is parsed by this telematics connector, and then ultimately the panic on alert is being sensed by the panic hyphen alert transformation, and this is ultimately pushed to the FMS solution and database based on the schema, based on the structure that an FMS solution requires. So let's go back, and now if you see that the data from the telematics device to start with, and this data on the fleet management solution to end with, and the database to end with. So let's go to the fleet management solution. Yeah, so this is one of the fleet management solution on which this data is being published. Yeah. So now, Mitra, if we could go to reports and showcase the data. Yeah, just selecting the time frame for which the data is being sent. So you could see that the data is being sent in a periodic way. And since the vehicle is not moving, the speed is zero, and then you have the status of battery connection, the ignition status, and things like that. So now ultimately you could visualize that the data which is sent by the telematics device is being used in the fleet management solution. So let's see the panic alerts. So now you could see that the panic alerts are generated and they are published onto the fleet management solution. So you could visualize that this complex use case, which is essentially getting data from a telematics device into a fleet management solution, whole of the building blocks which are passing data from the telematics device and then transforming this data into a required format or the required information, and then ultimately publishing it into a database and a fleet management solution. So we are able to achieve this in less than 30 minutes, but ultimately, if you try to utilize open source technologies, if you try to utilize tools without condense, it would take months together to facilitate this kind of use case. So now let's go back. Yeah. So this is the complete pipeline that we have built in less than 30 minutes. So this is the end of presentation that we are talking about. Of course, there'll be Q&A after this, where with which we can discuss on. If you have any questions, we could discuss there. As you have seen, with Condense, you can build streaming first vehicle intelligence apps in minutes, not in months. Whether it's generating data from panic alerts and ingesting raw data from telematics devices, all is facilitated by Condense. So essentially, Condense is a fully managed Kafka backend with pre-built connectors and domain-specific intelligent transforms, which you could utilize to fast track your GTM. And then it also houses custom built application transform framework, where you can bring in your applications from Git and then build them and publish on your connectors and start utilizing them on your platform. And all of this on the customer's cloud. All of this, the condensed features in bring your own subscription, and all of this could be deployed on customer's cloud and could be utilized. So this is just the beginning, and if you would like to try out Condense and then see how it fits into your use case, you could ping us.